In this video, let's talk about how to develop the random forest classification models and also how to develop the linear SVC. And then we will quickly compare the accuracies of these two models and how we can know that which model is the best and which are all the models. So check for scikit-learn map documentation. Just scroll down and here is the choosing the right estimator. Click on over here. So let's see how this works actually. So let's start with the start. If in case if we have more than 50 samples, let's go ahead. If in case no, get the more data. And are we predicting the category? So right now we are looking at the classification model. So it is not, it is a category, it is not a quantity. So S, and we have the label data S, and then here all the list of models. You can see this linear SVC, we can see the ensembles. So in this video, I'm going to use the linear SVC and I'm going to use the ensemble classifiers. You can also play with all the rest of the models. The syntax and everything remains same most of the times. And if in case if you're predicting a category like car price or flat rent, so for that you can start looking at these regression models. Let's focus on the classifications. Going back to this one, so to download the data, go to the Kaggle dataset. If you haven't used Kaggle for the first time, please sign up and then search for hard data disease dataset and click on the download over here to download the file. I already have downloaded and the file is over here. I have uploaded by clicking on this button and I have selected this one. So now I'm copying this one. So quickly let's import the data, import pandas as PD. If in case if you haven't watched my previous two videos, go to youtube.com codecraft with Raju Pujala, and here go to the playlist, and quickly there is a playlist called Mission Learn Classification. Click on that and you will find all of these videos. Okay, going back to our collab, import pandas as PD. So I'm just quickly uploading the data, pd.rate csv, right? Low memory, explain everything about the basics in my previous videos, do watch them. So df.head. Okay, so we have this one. So how many rows we have? We have 1025. Let's split the data. Split the data. So x is equal to df dot drop. Columns is equal to so all of these are the features and this is a target. So target comma axis is equal to 1 because I'm dropping the entire column. Y is equal to df dot target. So this is done. So we have x and y. If in case if you wanna see this one, you can see quickly. And now let's use scikit-learn models to split the data into training and test sets from sklearn dot model selection, import train test split. You can also use this one, import numpy as np.random.seed 42 x train x test y train y test is equal to train test split x y test size. I would like to have the test data set size is 20% of the original data. Random state is equal to, either you can use this random state or you can use the np.random.seed, and stratify is equal to here y because I would like this to go to the y column and split the data evenly. So this is done. So let's quickly check the size of the data. Xtrain dot shape, y train dot shape. Okay, so 820 820. So okay, fine. X test dot shape, y test dot shape. This is also good. So let's deploy our first model. So ML models, let's develop this one. So first one I would like to use like random forest classifier. Okay, from sklearn.ensemble import random forest classifier. So I just would like to give a shortcut to random rf as random forest classifier. N estimators is equal to 100. This is a default value. N estimators is equal to 100. So rf right? So rf dot fit x train comma y train. Okay, let's do the predictions. Y predict is equal to rf dot predict x test. And so using the test data features, we are predicting the values, and whatever the predicted values we have, we are going to compare with the original y test values, so that we will get to know like how accurately this is predicting. So this is also fine. Now we can't see anything, so let's import this model dot metrics, import accuracy score, right? So print accuracy score of y test, the original values and the predictions. Okay, right now it is showing 100, but in the real time data, it may show like some 53% or 54%. Okay, and so this is our first model, which is like random forest classifier. In the real world, if in case if we get like 100% accuracy, believe me, that's the best model. Okay, let's see with other models. I'm going to take linear SVC, right, from sklearn.svm. SVM is nothing but support vector mission. Import linear SVC. So linear SVC is equal to linear SVC. So I'm just copying this one to save everyone's time. Okay, this model is done. So dot fit same. If you can see like what exactly we have done for the random forest, we are doing the same over here, right? Right. So this is also done. If in case if you don't want to come across these errors, actually, and this is not an error, this is like a warning. If in case few of the packages or few of the modules in Python, if they're like deprecating in the future, they do give us these warnings. If in case if you don't want these warnings, you can write like warnings, warnings dot filter warnings, ignore. So once you run this one, um, oops, sorry, all the warning messages shall be ignored going further. And if in case if you want, if you would like to see the warning messages, just run this one default. This also works. Okay, let's go back to this linear one. Let's focus on this one, right? So we have fit the data. So y predictions is equal to linear svc dot predict x text. So okay, so it has predicted the data. This is good. Now from sklearn.metrics, we already have this one accuracy score. Just to ensure that you will not get confused, I'm just importing the library over here. Print accuracy score of the original values is the y test and the predicted values is the y prints. Let's see the accuracy score. Okay, now you can see that it is just 74% actually. It is not even warnings dot, filter warnings dot. Oops. Okay, this is still coming. So you can see the accuracy score is like only 74%. If in case if you would like to have this in a more structured way, so you can use this double quotes accuracy score on the test data set is, and then you can open this curly brackets. So it is linear SVC. It is accuracy score of y test comma vibrates, right? Can also do this one. It is like 74. If in case if you want to do some multiplications, yep, let's do that. 100, I just want only 2, and I also would like to have a percentage symbol. It is 74.3663. This is a good model, but still anything which is above than 70, which is considered as a good model. But right now, anyways, we already have used the random forest and we already have got 100%. So what I'm going to do, so let's write this one. So this one accuracy score of this one, I'm going to linear SVC accuracy is equal to this one, and then a random forest accuracy Okay. Okay. So we have both the accuracies. Let me do one. Okay. We have both the accuracies, and this is how we will see, like we will deploy the different models and see like which one is giving the better accuracy, and we'll go ahead. Please do watch the rest of the videos as well to learn end to end about the classification models. Thank you.